Okay, so in this lecture, we're going to look at computing inverses or determining when the columns are linearly dependent. Both of these will be done with what's called Gauss-Jordan elimination. So this is my example matrix, but I should write down our goal. So we want to determine a inverse, or if the columns are dependent. Linearly dependent comes from the right dependent. Note, A must be squared. Right? In columns, in rows. Okay, so the way that this works is by first setting up what's called an augmented matrix. So the augmented matrix is the block matrix AI, where I is the identity matrix. Okay, so what does this look like? I absolutely hate doing this in practice. You would just use a computer to do something like this, but I do it by hand at least once. Nope, that would have been A. The augmented matrix now is this block matrix. So here goes the identity. Yeah, right there. So here's A, here's I. Okay. So we have I need to emphasize that what we're doing here is exactly what we were doing with the matrix multiplication video. I don't know if you remember how I made a game of like trying to figure out what matrices to multiply. But this is kind of why I don't like Gauss-Jordan elimination, because really what we're doing is we want to know what matrix B times A is going to equal I. And that's the inverse. We want to find that, right? So all of the rules that I'm about to describe, it boils down simply to it's all multiplication by matrices, but the rules will be described a little different here. So here's the goal. As before, we want to produce ones on the diagonal. And the rules that we're allowed to do is that we can multiply by scalars and add any combination of the rows together. Okay? The number of ones that we eventually get will be the number of pivots. Okay, so the pivots are in these entries on the diagonal. And our goal is to make those ones and everything else zeros below the pivots. Okay, so for example, I can multiply this first row by 1/2 and add it to the second row to get the next matrix. So 1/2 times row 1 plus row 2 gives me. So the first row stays the same. Oh, I want a 1 right there. So I'm going to do that, and I'm going to just multiply the first row by 1/2. So this will be a 1 now. This will be a minus a half. And this will be a half. And if I added that to this row, I get 0. So minus a half plus that's 3 halves. This negative 1 stays the same. 0, 1, 0. And then we didn't do anything to the third row. Again, the whole purpose of this is to build the identity right here. Okay? And I think of this like this. We want to know what times a is equal to the I. And that's like what I'm thinking is happening. Okay, so, all right, so now, okay, we still don't have the identity matrix over here. I want to multiply this row by 2/3. So we do 2/3. That's going to make a 1 there times row 2. And then what else are we going to do? Then 2/3 times, so 2/3 of row 2 plus this. So there'll be a 1 there, and then that minus will go away. And then plus, and then and row 2 plus row 3 after we do that, or something like that. So, so first row stays the same. This row now is going to be, so it'll be a 1 right there. Negative 1 times 2/3 will be negative 2/3. 0, 2/3, 0. And then we added this row to this one, so that'll be 0 there, 0 there. So negative 2/3 plus 2. So 2 minus 2/3. So 4/3. 6. Right, yeah, 4/3. And there'll be a 0 right here. And then there'll be 2/3 here. No. What is it? 2/3 times row 1. So yeah, it'd be 2/3 here. Sorry, 2/3 times row 2 plus row 3. And then there'll just be a 1 right here. Okay, we're almost there. So then we can do 1/2 times row 2. So we want the identity matrix here as a block. So 1/2 times this row plus that row. We'll get rid of that entry there. And then, but when we do that, we're going to have, and then we're almost there. I guess we'll just multiply row 3 by 3/4. So what's the resulting matrix then? So 1/2 of row 2, there'll be a half plus that, it'll be 0. A half of that there. So that's minus 1/3. A half of that plus that is just 1/3. And then 0. 0, 1 minus 2/3. 0. 2/3, 0, and then I multiply this by 4/3, so 0 there, 0 there, 1, 0 there, 4/3 times that, so that's 1/2, and 0. I know. Sorry, 3/4. All right. Keep on saying 4/3. It's really 3/4. Okay. All right, and then we just have to get rid of that, right? And we have this pivot here. We can multiply it by this row by 2/3, add it to this, and by 1/3, and add it to that, and we'll be done. So let's see what happens. So 1/3 of this plus that row. Okay, so what is that going to give me? So 1, 0, 0, 1/2. 1/3 of that row. So that'd be 1/6 plus 1/3. 1/6 plus 1/3 is, why am I not thinking right? Oh, it's just 3/6 or 1/2. And then 1/3 of that, so there'll be a 1/4 here finally. Okay, and then we want to do 2/3 of row 3 plus row 1, row 2. So that'll be 0, 1, 0, 0, and then negative 2/3 of, 2/3 of this, so that'd be 1/3 plus that, so 2/3 plus 1/3 is 1. 2/3 times this, 1/3 plus that. Okay, that's 1. And then 2/3 of this. What is it? 2. Is that just a half again? 2/3 times 3/4. It's a half. And then the last row stays the same. All right, so this block here, right here, is now the identity, which means this, through these operations, has produced the inverse. And we can verify that right now. So let's just do it. So, oh, that's going to be such a pain to do. All these fractions everywhere. And I really hope I didn't make any arithmetic error, because it was so easy to make an error. All right. First column, let's take our time. 2 times the, 2 times this, minus that, 0 that. So it's just 2 times this column minus that column. Two times that doesn't look right. Where did I mess up? What is the inverse? somewhere I got the first column wrong. Why are there always these zeros right here? Somewhere I got it wrong. Everything else is fine. It's just this column is off. Oh, I really don't want to do it again at all. Okay, it's annoying, but I don't feel that it would be appropriate for me to just write down the correct entries right there. So let me try this again one more time. I'm going to move quick this time. I'm not going to explain anything. I'm just going to keep note of the operations. I hate this so much. 0. 0. 2. Make sure I wrote down the right matrix. 2 minus 1, 0, negative 1, 2, negative 1, 0, negative 1, 2. Okay. All right. I'm going to put a line here to distinguish 1, 0, 0, 0, 1, 0, 0. No, okay, so all I did was multiply the first row by a half. Now I'm going to add row 1 and row 2. So that means that row 1 stays the same. I already caught one of the mistakes. I see a half there, and there's not a half there, but there should have been, because I'm adding this row with that row. That 1/2 goes there. Didn't do anything to the last row. Okay, I'm moving. Okay. So now, it's too blurry up there. Okay. So 1/2, minus a half, 0. 0, 0. Now I'm just going to multiply this row by 2/3. Two-thirds times that is just a third. And then 2/3, 0. And then after I multiply that row by 2/3, I'm going to add it to this row. Right, because I want to zero out that entry there. So 0, and then that 1 and that 0, and then 2/3, so 2 minus 2/3 is going to be 6 minus 2/3. So 4/3. Okay. And then so this will be a minus 1/3 there now. Or no, I'm adding it. It should be 1/3. Adding that row. And then 1 plus 9. So it would be just 2/3 here. And then this is still 1. Okay. So then I'm going to multiply this row by 1/2 and add to this. 1, 0, minus 1/3 by 1/2, so 1/6 plus 1/2. What is that? 4/6. 4/6 just reduces to 2/3. Half times this plus that, which is 1/3. Still a 0 there. 0, 3, 1/3, 2/3, 0. And we multiply this by 4/3. 0, 0, 1, 4/3. This would be 4/9 now. 4/3 times 1/3. Oh, wait a minute, no. I'm multiplying by 3/4 to make that a 1. So 3/4 times that is just 1/4. 3/4 times that is just 2/4 or 1/2. 3/4 times that 1. So now, if I'm very careful, I can do this all in one go to get rid of that and that. So 1, 0, 0. So what did I do? I multiplied this by 1/3 and added it to that. So this by 1/3 is 1/12 plus 2/3. What is that? 1/12 plus 4 times that 2 is 8/12. So that's 9/12, or just 3/4. Swear if this is not right, I'm going to be so bummed. Okay. So I multiplied this. So wait a minute. Let me make sure I did this. Oh, no. This by 1/3. Added it there. So 1/3, 1/12. What's that? Okay. So this by 1/3. So this is 1/6 plus 1/3. 1/6 plus 1/3. What is that? That's going to be 3/6 or just 1/2. Okay. Am I right? 2/6. Yeah. 3/6 is just 1/2. 1/2 right here. And then 1/3 times that is just 1/4. What's that? 0. And then I multiplied this by 2/3 and then add to this row. So 0, 1, 0. So 2/3. So 2/3 times 1/4. I'm just being very careful right now. So this is like 1/6. Right? So 2/3. So 1/6 plus 1/3 is 1/2. 2/3 times this is 1/3. 1/3 plus 2/3 is a 1. Okay, 2/3 times this is just a half, right? And then 0, 0, 1, 1/4, 1/2, 3/4. Okay. Yeah, that's it. That's the correct answer. Okay, finally, we can check that this procedure known as Gauss-Jordan elimination did indeed give us the inverse. Notice that there are 3 1s on the diagonal, so the number of pivots is 3. So number pivots is 3. That's a good thing, because there's 3 columns, and we'll get to that in a moment. So let's just verify that everything is working. This mess of a inverse. Okay, so let's go ahead and work out what the first column is going to be. 3/4 of this one plus 1/2 of this one plus 1/4 of that one. So the first entry is not too bad. So 3/4 of 2, so it's like 6/4, which is just, what is that? 3/2. 3/2 minus a half is 2/2, so it'll be a 1 right there. So 3/4 of that plus 1/2 of that plus 0 in there, give me a 1. In this entry, we have 3/4 of, so negative 3/4 plus 1/2 of 2, so plus 1 minus a 4th. So 3/4 minus a 4th. So negative 3/4 minus 1/4 is -1 plus that 1 is a 0. Okay, now this entry here, so 0 times 3/4, -1/2 plus 2/4 is 0. It's -1/2 plus a half. So we see that 1, 0, 0. For this column, we do the same thing, but now this times the matrix. Okay, so it's 1/2 of this plus 1 of this plus 1/2 of this. So 1/2 of this plus 1 of that, I automatically get a 0 there. 1/2 of that is -1/2 plus 2 minus another half, that's going to be a 1. 1/2 of 0 plus 1 of that. And make sure I'm doing this right. 1/2 plus 1 of this. 1/2 plus 1 plus a half. Oh yeah, it's -1 plus 1, which is 0. Okay, and then finally, that column times the matrix, 1/4 of this minus 1/2 of this, no, 1/4 of this plus 1/2 of this plus 3/4 of that. 1/4 of 2 is 1/2 minus a half and then 0, 0. 1, so -1/4 plus 1 minus 3/4 So 0. And then finally, there. Okay. So the pivots are where you get your ones along the diagonal. And the important thing is that if the number of pivots does not equal n, the number of columns, it's not invertible. In this case, it did, so it is invertible, but if we would have only been able to get 2 ones, and like that would have, if this would have become a 0, and then it would mean, oh, if that became 0, the number of pivots would just be 2, and then it wouldn't have an inverse. But if the number of pivots is equal to the number of columns, it has an inverse, which also means that the columns are linearly independent. Okay. All right, so let me go ahead and stop this recording.